In the previous video, we gave an overview of chemical bonding, and the first widely accepted theory by chemists was developed by someone named Gilbert Newton Lewis, which he referred to as Lewis theory. So let's kind of go over some of the key points from Lewis theory. This theory states that only valence electrons play a fundamental role in bonding. This is why when we're writing our electron configurations, we can conveniently use the noble gas core, because only these valence electrons are going to be key in the bonding. Also from this theory, chemical bonding resulting from the transfer of one or more electrons from one atom to another leads to the formation of positive and negative ions, and the attractive force between these oppositely charged ions is called the ionic bond. We can also say that chemical bonds involving the sharing of electrons between atoms is called a covalent bond. So an ionic bond involves the transfer of electrons, whereas a covalent bond is sharing of electrons. Another big statement is that when electrons are transferred or shared, each atom would acquire the electron configuration of a noble gas. And we refer to this as the octet rule. And what Lewis did was he came up with a notation that he used for the main group elements displaying their valence electrons, and we refer to these as Lewis symbols. So for example, cesium has one valence electron, which is a 6s1. So when he displayed these Lewis symbols, Lewis indicated how many valence electrons each atom has by putting a little dot next to them. For aluminum, we need to show that it has a 3s2, 3p1 valence electron configuration. So for aluminum, we need to put 3 electrons around that central atom. For carbon, we have an electron configuration of 2s2, 2p2 for its valence shell, and we will place 4 electrons around the carbon. For bromine, its valence electron configuration is 4s2, 3d10, 4p5. And what we're going to find is when we have a completely filled subshell, such as this 3d10, we can ignore that because that completely filled D subshell is not going to be involved in bonding. We can say the same for a completely filled F subshell. So if we have a D10 or an F14, we do not consider those valence electrons, and therefore we don't need to write those electrons in our Lewis structure. So for a bromine atom, we need to indicate that there are 7 electrons around that bromine atom. And using the foundations from the theory that Lewis developed, and also looking at these Lewis structures showing the valence electrons, we can now start to investigate how the bonding is going to work. And in the next 2 videos, we'll talk about ionic and covalent bonding and how we can use these Lewis structures to represent the bonding that happens when a compound forms.